All right, so in this video, we're going to look at this quiz from lessons 4.6 to 4.9 to make sure that you're ready and know what you need to do for the test that you'll be taking. So remember, the order that the questions pop up here on my quiz will probably be different from yours. All right, so this is looking at the equation y equals 3 times the cosine of 2/5 x. And we need to find ultimately, we're going to be finding the amplitude and period of the function along with, but first we're going to answer these questions. So first off, this first part says, compared to its parent function, vertically the graph would be, it's going to be stretched or compressed to be how many times? So at the beginning there, we have the 3 times the cosine of 2/5 x. And so that 3 is going to affect the graph vertically. And so that's what we're going to focus on right now. Remember, that stays the way it is, so we don't have to take the reciprocal of it. So this would be since it's bigger than 1, it's going to be a stretch. So just put an S there. And it's going to be, like I said, 3 times the size. Now the 2/5, remember the 2/5, that's going to be how the graph is going to be affected horizontally. But we have to take the reciprocal of that. The reciprocal of 2/5 would be 5/2. And 5/2 as a decimal is bigger than 1. So this would be a stretch as well. And you could either put 5/2 here, or if you put 2.5, that would have given you the correct answer as well. So either way, 5 or 2.5 would be your answer there. Remember, your amplitude is whatever the value is in front, and so the absolute value of it, and the absolute value of 3 would just be 3. Remember, to find the period, we would take the reciprocal, that 5/2 times 2 pi. Well, when we do that, the 2's would cancel out, leaving us with 5 pi. The pi is already there, so we just say 5. All right, so this one's asking us to use a periodicity theorem to find a value between 0 and 360 that's equivalent to the sine of 1950, the sine of 1950 degrees. Well, remember, the periodicity theorem for the sine function tells us it repeats itself every 360 degrees, or 2 pi radians. Well, this is in degrees, so we'll use a 360. So I'm going to take 1950 divided by 360. When you do that, we get a decimal of 5.416 repeating. This 5 tells us that this represents 5 revolutions, or 5 times around the circle. And so I want to figure out, okay, so this is 5 full revolutions, or 5 full rotations, with a remainder of 0.416 repeating. So I'm going to take that 0.416 repeating and multiply that times 360 degrees to figure out how many degrees past 360, or how many degrees past those 5 full revolutions that would be. And when you do that, you get 150 degrees. And so the sine of 1950 is equivalent to the sine of 150. All right, for some reason it's not allowing me. Oh, there we go, 150. There we go. All right, so this is a drag and drop problem. So this is the toughest one. I would recommend first kind of thinking through the process here, thinking through what's going on with this equation. So let's start with the 1/3. So the 1/3 means that this is going to be a vertical compression because it's between 0 and 1. So I'm just going to say this is a vertical compression of 1/3. The 4, now I did this, I was nice to you. Instead of having this all as one piece, I already factored out the 4 there, so you can see it's 4 times that quantity. So that 4 represents the horizontal, or what's happening to the graph horizontally as far as if it's going to be stretching or shrinking. Remember, we have to take the reciprocal of 4, so that'd be 1/4. So this would be a horizontal, since that's less than 1, it's going to be a horizontal compression of 1/4 the size. Now the x minus pi over 4 means it's going to go to the right pi over 4 units, and the plus 3 means it's going to go up 3. So this information will just help me as I answer these questions. Remember, that amplitude, is equivalent to whatever the 1/3 is. I can't just highlight that, I guess. The 1/3 is going to give us our amplitude. So our amplitude, again, we'll just drag that 1/3 there. There we go. So the amplitude would be 1/3. So the period, remember the period, we get that from what's happening horizontally as far as it's going to be stretching or shrinking. And so it's going to be 1/4 the size horizontally. Well, remember, 1 period typically would be 2 pi. So if I take 1/4 of 2 pi, I would get 2 pi over 4, which reduces to pi over 2. So that would be my period, would be pi over 2 radians. All right, so my phase shift means that it's going to go to the right pi over 4 radians. So my pi over 4 would be my phase shift. My vertical shift, it's going up 3 units, and so we would just say our vertical shift would be a positive 3. So that's how you would answer that one. All right, so this is another one of those periodicity problems. Now remember, the tangent function does not repeat itself every 360 degrees. It repeats itself every 180 degrees. So for this one, I'm going to take 1,295 and divide it by 180. Now when I do that, I get 7.194 repeating. So that means it represents 7 full rotations or repetitions of that tangent function with 0.194 repeating left over. So I want to figure out, well, how many degrees would that remnant be? So we're going to take 0.194 repeating times 180, and when we do that, we get 35 degrees. Now, if you got an answer of 215 degrees, well, there's a couple things that's wrong with that. If you got an answer of 215 degrees, it means that you used 360 instead of 180. So you got to remember that the tangent function repeats itself every 180 degrees. So you got to divide by 180 instead of 360. The other indicator that that would be wrong is because it says here to find a value between 0 and 180. So even though the tangent of 1,295 degrees technically would give you the same value as a tangent of 215 degrees, the problem is 215 is greater than 180. So a couple indicators there that you would have had the wrong answer if you had 215. All right, let's look at the next one. So the next one says, which of the following equations would have an amplitude of 4 and a period of 2 pi over 3? All right, so to answer this question, let's think about this for a second. So if it's going to have an amplitude of 4, none of these that have 1/4 as an answer, none of those could be a response. Okay, so I'm going to ignore those that have 1/4 because, again, if it's got an amplitude of 4, it's going to have 4 in the beginning. So it's going to be one of these 3. Now you could have used those 3 and just worked your way backwards and figured out which one would have a period of 2 pi over 3, but let's think about that for a second. If it's got a period of 2 pi over 3, 2 pi over 3 is the same as 1/3 of 2 pi. Okay, that's what I think of here. When I see 2 pi over 3, I see that that's the same as 1/3 of 2 pi. Well, remember, we're going to use that 1/3 then to figure out how we're going to be stretching or compressing the graph inside of parentheses here. All right, so that means that I would take the reciprocal, because remember, we're going through this description as far as what's really happening, so it's going to be 1/3 the size horizontally. So when I'm thinking about what's actually happening and I go to the equation, I have to take the reciprocal. The reciprocal of 1/3 would just be 3. So that tells me that this has to be my equation. Because again, if I wasn't given this information at the beginning, if I was just given the equation, I'd be able to see from this 4 that it would have an amplitude of 4. Okay, it meets that criteria. And I would take the reciprocal of 3, which would be 1/3, multiply that times 2 pi, and I would get 2 pi over 3 to get a period of 2 pi over 3. And so now I can see that this equation meets both of those criteria. All right, so for this one, I want to figure out what equation would this blue line be. Okay, so I want to figure out how is this red line being translated to this blue line. So I see that this peak here, so the sine function, remember, has x-intercepts at pi, and it has your maximum value here at pi over 2, and at 3 pi over 2 would have a minimum. So anyway, so I gave you that, so in that way you don't have to think about it. So this would be at pi over 2. That new peak now is at 5 pi over 6, so it's been moved to the right from pi over 2 to 5 pi over 6. So I want to figure out how big of a translation that would be. So I'm going to start with this larger value, the 5 pi over 6. Whoops, don't want to have a highlighter here. So So I'm going to take that 5 pi over 6 and find the difference between that and pi over 2. Well, in order to subtract these, we have to have a common denominator. So I'm going to change that 2 to have a common denominator. So I'd multiply the top and bottom by 3. So in that way, I would have a denominator of 6. So 3 pi over 6, you should know, is the same as pi over 2. So now we can subtract these. So they have a common denominator, so we would get 2 pi over 6. Now I want to reduce that. So 2 6 reduces to pi over 3. So that means it's moved to the right pi over 3 units. Now you got to be careful. If it's moved to the right pi over 3 units, that means that in our equation, it's going to be x minus pi over 3. So since we have a plus here, we need to put in a minus. And then I'll just type in the words pi divided by 3. And then it's moved up from this value here, where y would be 1. It's moved up to 5, so it's moved up 4 units. So we would put just 4 there. All right, so this one here, we have everything, or this is in degrees. So this x minus 70 degrees means that it would move to the right 70 degrees. So I'm going to put that here. There we go. And this plus 5 means that it would move up 5 units. So we put the up 5. And that second box is your vertical shift. So that's how you answer those questions. So hopefully hearing that will help you understand the ones that you got wrong. If you did have any questions still from any of these problems on the quiz, please make sure that you reach out and ask me and figure that out, so you know what to do going into the test.